Don's Hi, welcome to Don's Manufactory. Yes, I am still working on suspension, trying to figure stuff out. Had me an idea today that I have to try out. I just have to try it out. Steering angles, toe angles, are different right to left. The right side is dang near perfect. The left side is still, if we look at it this way, the passenger side has just, it's within 1.5 millimeters of just going straight up and down. I mean, that's how close it is to being perfect. The left side is doing, is it 10 millimeters? 12 millimeters. It was 14, but I made some adjustments and I got it down to like 12, but still, so it is still doing a lot of toe in, toe out, while the right side is just going up and down. And I am attributing this to the fact that I machined the steering box and the sector shaft is lower in the steering box, which lowers the Pitman arm and lowers the drag link on, or center link on, the driver's side of the car. So the angles aren't equal. When you go under the car, the drag link is low on the driver's side, so then the steering arm has less angle to it, so it's shorter. This one is shorter than that one, and when you manipulate it, it has a completely different toe curve than on this side, where the inside attachment for the tie rod is higher. So I don't know if I just accidentally hit it right on the money when I was doing the Delrin bushings and the idler arm, but whatever I did on the right side, I absolutely nailed it. I'll say by accident, and it's perfect. Now I just have to get the driver's side to do the same thing. I am sort of not in a favor of using these because of the limited travel and the fact that I have to bend the tie rods in order to be able to use these. So I haven't wanted to commit to using a bump steer, which I could do on the driver's side to cure my problem. But what I'm going to do instead is I'm going to look at whether the sleeve that's inside the frame allows me to actually slot the frame rail a little bit, and it will allow me to adjust the steering box up. I'm going to look at that. I'm going to look at the stock Pitman arm. Can I use the jeweler files to take a few thousandths off the teeth inside this Pitman arm so that it slides up the sector shaft further? I only have to go up 100 thousandths. Or is it possible to put more of a dog leg in it? Because basically what has to happen is this Pitman arm needs to be just 100 thousandths higher on this end. So however I accomplish that elevation of the Pitman arm on the driver's side will probably make the steering acceptable. And I don't know if it's possible to bend these. I mean, these are forged units. I don't know how hard they are, but because they're forged, I am going to assume that they are probably somewhere in a 30 Rockwell or so. Not, you know, brittle hard like tool steel, but not soft like mild steel. Today I had a couple ideas to try. I don't know about machining this, but I've got my old Pitman arm that I can just try machining it, and then I can go ahead and put it on the car and see if it works. If I can do that thing with the steering box, make it adjustable, and then assemble the steering column and all that to make sure that when I raise up the steering box that it doesn't put the steering shaft into a bind and get the Pitman arm to go up that 100 thousandths, then that's a done deal, because that's 10 minutes with a die grinder. Pitman arm update. This Pitman arm here is 485 thousandths offset. This Pitman arm here is 530 thousandths offset. The one I got from Randy down at Precision Parts has a 585 thousandths offset. So it has 100 thousandths more than this one. So what I tried doing was filing the splines on the inside of this, well, on the inside of that one, to see if I could get it to slide on a little further. And I succeeded. It slid on a 1/16 of an inch further. But I need to go another 1/16. So I have to take it all apart again and do some more filing and then put it all back together again. I don't know how well you can see this, but what I have done here is filed a little bit of material out of the splines. I also cut back, put a little chamfer right on the edge here, because the sector shaft has the splines that go up and then it has a curve out, and I wanted it to go up a little higher before it hits that curve and locks into place. And we will see if that works. I just need a 1/16 of an inch. Hi, welcome to Don's Manufactory. Today's update. I've gotten close with the suspension. Driver's side still isn't right, so I have to figure out how to get the Pitman arm onto the sector shaft further. So essentially, the stick out of the sector shaft has the Pitman arm too low and is throwing the steering geometry off. So I need to have it slide onto the shaft further. And that's my project for today. And besides that, I'll be taking the driver's side suspension and moving the control arm, the upper control arm, back into the stock position and then mapping the geometry. I don't have that data yet of how the suspension reacts in its stock form, so I got to get that. And I'll do that in time lapse so you guys can see it. I don't know, it's awfully darn boring. Another thing I did was I cut these blocks. Because I'm not going to be measuring from the floor, I need to be able to set the suspension exactly the same each time, both sides, as I take measurements. So these are blocks that I will put between the control arm and the upper snubber. I can just pull it up to that and then run the wing nut down to hold it. That's it for today. That's what I'll be doing. Enjoy the slideshow time lapse, whatever you want to call it, and let's get to it. Well, I'm just inspecting the splines, making sure that while I'm filing, I'm fitting it to the splines on the sector shaft really well. Lots of light, take my time, just do it as accurately as I can. It took a little bit of doing to get this exactly the way I wanted it. I actually got it back on the car, realized that I had misfiled a couple of splines, and so I tore it back apart just so I could fix those splines. Anyway, so that is the process, and then I just got to get it back in the car, of course. Okay, down underneath, putting things back together. No, you don't use impact wrenches on the steering box, and you don't use the internals to torque against either. Okay, so here I am. I'm measuring the steering links and measuring the angles of the all the steering lengths and everything. I'm just trying to make sure that everything is equal on the underneath side. All right, changing the perspective. Now I have to assemble my measuring system. I'm using the laser to go down the center line. I've got a plumb bob in the back that lights up when I hit it with the laser, and I can split the core support in half by the hole right in the front, and then I can get everything lined up exactly on center. And you see me duck inside the car every now and then. That's me adjusting the steering shaft a little bit left, a little bit right, until I get the drag link exactly in the middle. And you'll notice my steering shaft has to be 2 splines left to center the steering links. Here is a shot of the boards I am using. So there's a center line right there. Then 24 inches over, there's another reference line right there. And you'll notice that that's where this ruler starts, right at 1 inch. So these are lined up. 24 inches on the other side of it. And by golly, those are lined up too. And if I put a tape measure across the whole thing, it measures perfect. So these are exactly the same, and this line here is exactly the center. Okay, during these endless hours of me taking measurements, let's move on to looking at the data. Okay, so we're going to start off with the stock suspension. So here is the first graph. So you'll notice that the camber is actually just a arc. Just looks like a little hump. And this makes perfect sense to me because the control arms are unequal lengths and they are almost parallel. So the top control arm is going to run out of sync to the lower one and pull the top of the spindle back, causing the camber to go negative on both ends. Looking at the toe curve, you can see there is about 13 millimeters of toe angle change with the stock suspension. Just for the heck of it, I decided to throw some caster at the stock suspension just to see what the reaction was. And you can see that 4.5 degrees of caster actually flattened the toe curve pretty well. Of course, it's showing a toe-in condition under compression, which would cause oversteer, so I wouldn't go this far, but 2.5 degrees of caster thrown at a stock system would make it handle pretty well. All right, so here is the chart for the passenger side that just, I don't know, accidentally was perfect. Okay, looking at the camber curve, it looks pretty good. It's a little steeper than it should be. The caster curve looks normal. The toe curve, look at that. It's got 0.0000000 on compression there, starting at about a half, or what is it? No, 1 millimeter of toe in, which is, less than a 16th. But it was a really great looking curve, and I just kind of decided, you should stop there. Okay, now for the painful part. Here's the driver's side. After doing my best to try to get stuff going, I mean, you can see camber and caster curve look the same as the passenger side, but look at the toe curve. 16 millimeters of toe change. That's like 5/8 of an inch. It's pretty bad. Just to note that while it says degrees off to the left for the caster camber, that's actually millimeters as well. I started measuring this whole thing in millimeters because it just charted so well. Okay, here's the chart after I discovered that the steering shaft, the centering mark on the steering shaft was not accurate, and I then recentered all the stuff on the underside of the car. You can see that the The toe curve, caster and camber curve are the same, of course, but the toe curve is now what, 13? It's well, it's still 14, but it's less than 16. So there was an improvement when I recentered everything underneath. Okay, next up, the Pitman arm has been filed and the car reassembled, and you can see that, okay, now I'm down to 11 millimeters of toe change. Naturally, I don't know, there's a little bump here in the caster curve. It's got to be just measurement anomalies. But yeah, I'm only 10 millimeters with 3 inches of extension. So that was better. Okay, so here's the driver's side final. And you can see that, oh my gosh, look at that. It's starting to look like the right side of the car. Not that bad. I've now cut the toe change down to about 8. So let's look at the left and the right side together to make a comparison. Well, here we can see that the two curves are very, very similar. Notice that the passenger side has taken on some of the traits of the driver's side, and that's because when the driver's side, the Pitman arm was raised, that actually changed the angle of the passenger side too, because naturally it's all part of the same system. Anyway, at this point, I don't know whether this is bad or good because I have no way to compare what I'm looking at to how the car is going to drive. So that's the next step. I have to drive the car, and if I need to change something, I will. I may need to back out some of the caster and flatten that toe curve some more, or something like that. I don't know yet, but I've sort of arrived at a point where I have to go drive the car to know whether what I have done is actually a success. I suppose that if I had to, I could weld up the holes in the shock tower and change the amount of Shelby drop. There's a lot of stuff I can do. I can change the amount of anti-dive. I've even thought about buying a shock tower replacement and build a jig and set up a whole side of a front suspension and then slot the holes in the shock tower so I can move the upper control arm anywhere I want and then just move it around until I get perfect suspension, and then that would become the new standard. This is what I do to suspension, I know that if I change the anti-dive, it's going to change the caster curve, and that might help the toe. And boy, it just goes on and on and on. Anyway. Well, I'm surprised you made it this far. If you're still watching, that was a lot of data to get through. I tried to do it as quickly as possible. I do have all the numbers if you're interested in seeing the numbers, the data, the other charts, the spreadsheets and everything of all the data. I don't know. It's pretty mind-boggling. Say something in the comments if you know what these suspension curves look like and how that corresponds to the way the car handles. Put your comments in here. I'd really like to know. I've never done this before, gone this deep into suspension and made these kinds of changes to get this kind of result. And the fact that these Pitman arms are so different. The difference between these two Pitman arms right here are enough to throw your steering way off. This one would cause bump steer. This one would not. I mean, there are 100,000ths difference in these two Pitman arms as to where your drag link is going to end up. Oh man, I tell you, it's just so interesting because this is the plight of aftermarket parts too. Anyway, thanks for watching. and I'll catch you later.